This video is about proving lines parallel, part 1, and it comes from your text, section 3-3. What do you think? Are these two lines parallel? Now what do you think? What if we don't know whether two lines are parallel? What if we're not given that information in the problem statement? Is there some way we can use other information to prove two lines are parallel? Recall from earlier that we had the corresponding angles postulate. That was what we started with when we wanted to use parallel lines to prove things about angles. It said that if two parallel lines are cut by a transversal, then corresponding angles are congruent. So we were told two lines were parallel, and we were able to deduce that corresponding angles were congruent. And if the lines were not parallel, the corresponding angles were not congruent. But is the converse true? If two parallel lines are cut by a transversal, then corresponding angles are congruent. We know this because that's a postulate that we already have. Let's break this sentence up into the hypothesis. Well, let's see, the hypothesis is going to be this whole thing. And the conclusion, corresponding angles are congruent. What happens if we make the conclusion into the hypothesis and the hypothesis into the conclusion? You may remember this term converse. You know that we switch the hypothesis and conclusion to get the converse of a statement, and you may remember something about whether the converse of a statement is true or not. Let's see what you think. In this case, we know that the converse is true because it's actually another postulate. Since the converse is also true by the corresponding angles postulate, we have a biconditional statement. If we start by knowing that two lines are parallel, we can deduce that corresponding angles are congruent. Now, if we start by knowing that corresponding angles are congruent, as we can see in this diagram, we can go this direction and deduce that the lines are in fact parallel. So given this new postulate, what else can we prove? For example, is the converse of the alternate interior angles theorem true? Could we say that we already know that if lines are parallel, then alternate interior angles are congruent? But do we know that alternate interior angles being congruent makes two lines parallel? So to sum up, this is the direction we know. And today we're going to try to prove that given alternate interior angles are congruent, we can show that two lines are parallel. Okay, here's a diagram of two lines. Notice that I have not marked parallel on these lines because we don't know whether they're parallel or not. We do know that there are two lines cut by a transversal. And if I were writing a flowchart proof, I could just write diagram, or to be more specific, I could write transversal T cuts lines K and N. I have another given in this case, and it comes from my if statement. We're trying to show that if alternate interior angles are congruent, then the lines are parallel. So this given comes from my if statement. If alpha is congruent to beta. In other words, if two alternate interior angles are congruent, can we prove something about these two lines? So when I start a proof, I write down my givens, and I'm going to make them orange in this video. And I also start by writing down what I want to show. So take a minute and think about what you would write in this pink bubble. Again, we want to show, in this case, that the two lines are parallel. So what goes in this pink bubble is line K is parallel to line N. That's what we want to show. We have not yet shown it. Okay, let's start with our first given, which is the diagram itself. From this diagram, we started out by just labeling angles beta and alpha. By the way, it's nice to know some Greek letters because oftentimes mathematicians do label angles that way. And from the diagram and from what we know about vertical angles, we can deduce that angle beta is congruent to angle gamma here. That just came from the vertical angles theorem. And I've made this bubble green because it was a deduction that we showed from one of the givens using a theorem that we already have. Okay, let's take our second given, which is that angle alpha is congruent to angle beta. We just showed in the last slide that angle beta was congruent to angle gamma. So what postulate or rule could we use, and what could we deduce from that? Well, what I notice here is that we can apply the transitive property. Alpha is congruent to beta, beta is congruent to gamma. Therefore, by the transitive property, alpha must be congruent to gamma. So let's mark that on our diagram. Alpha is congruent to gamma. What kind of angles are these? That may be looking familiar to you. Okay, we just showed that alpha was congruent to gamma. And let's keep our end goal in mind. Our end goal is that we want to show line K is parallel to line N. What could we combine with the information we just showed? What other claim can we combine with that? And what rule would allow us to make that deduction to show that K is parallel to N? What do you think? Given the diagram, and given that alpha is congruent to gamma, we have the corresponding angles postulate, which we just learned at the beginning of this video, which says that if we have two corresponding angles that are congruent, we can be sure that the two lines are parallel. So by that postulate, I can deduce that line K is parallel to line N. And that was our end goal that we wanted to prove. So here's the whole proof laid out for you. I want you to notice one thing, which is that I've made my givens in orange. And my two givens are in different parts of the flowchart proof because well, first of all, givens don't need to have any arrow that leads to them. So we don't need to have an arrow coming into a given. There's no arrow leading into this given either. But each of the givens comes into the proof in a different way. There's this line of reasoning, and then there's this line of reasoning, starting from this given. And these two lines of reasoning have to join up in this step right here. They combine to make the deduction that angle 1 was congruent to angle 3. So when you make a flowchart proof, I'd like you to try to separate your givens and start a different line of reasoning, possibly from every given, or maybe just one given would start a different line of reasoning. In other words, not all the givens are going to be used at the same time. They'll be combined throughout your proof with maybe other deductions or possibly other givens. They'll be combined to make a deduction that you're looking to make. Okay, so what we've proved, in other words, is that it is true that if alternate interior angles are congruent, then we can claim that the lines are parallel, just as we hoped. For further practice with constructing proofs, see page 87 of your book, number 17, and page 88, numbers 23 and 25.